So we are going to work on this textbook problem, that is points P and R are located on the opposite sides of a straight river that is 2 kilometers wide, and we have to lay a pipeline from P to R. So part of that will be underwater and part of this will be on land. And the distance from this point O, which is straight across from P, okay, I mean, this is 2 kilometers, but this distance O from R is how many? 6 kilometers. So what we have to do is that we have to find the location of a point Q such that laying the cable from P to Q along the river and then Q to R along the land is minimized, and the cost is given here, 400,000 per kilometer on land and 800,000 per kilometer under the river. So this is the question that we have to solve, and we are given the picture here, and just pause it and read it again if you would like. So what I'm going to do is that I'm going to start with the routine procedure. That is, I'll assume that this distance between O and Q is how much? Let me make it thinner. Say that is X, okay? So this brown distance will be how much? That will be 6 minus X, right? Because this whole thing is 6. And then this distance here, that is the length of the pipe under the river, that is going to be the hypotenuse of this right triangle. All right. And that hypotenuse would be how much? The legs are X and 2. So the hypotenuse would be square root of X square plus 4. So what we have to do is that we have to minimize this cost, that is 800,000 along this line, right? And 400,000 along the rest. So what we can do is this, that if we factor 100,000 out, then the question changes to this, that is 100,000 here is a factor, 100,000 here is a factor. So the question just changes to minimizing this function, a function of X, and that will apply even if we take 100,000 times it, okay? So let's go ahead and do calculus with this. That is, our question now simply is a mathematical question. Expression is written by like this. So I'm just going to go to a different calculation board. All right. So we have to find the minimum of this function, and you can see the domain of this function is the entire set of real numbers. So first thing to do would be what? To just go ahead and find the derivative of the function. Let's do that. Okay. So if we write the derivative, okay, what we get is this. That is, we will have 8 times the derivative of this quantity. And what that would be according to chain rule, you will have first derivative of a square root is how much? 1 over 2. The same square root of the quantity that you have, but the quantity is x square plus 4. So by chain rule, we will have to write that quantity upstairs. And then we have this multiplied by how much? 8. Let me just put multiplication sign prominently here. Now for the derivative of this portion, you see 4 is a constant and 6 minus x, the derivative is -1. So those two will multiply to how much? -4, right? So our f prime x becomes how much? These twos will cancel. So we will have f prime x equals, just a moment, that equals, so 2's canceled, and so we can just bring this 8 up here after canceling the 2's. Okay. Now, in order to get the critical values of x, what we have to do is we have to set the derivative of f equal to 0. So let's just work on it. we can add 4 to both the sides. All right, or we could have divided by 4, whichever way you please. Now we can divide both the sides by 4, and then what that will produce is simply this. If we divide both the sides by 4, we get how much? 2x, because 8 divided by 4 is 2, and that equals 1. Then let's further simplify this here. So when we do that, what we have is, so we got this, and that will mean that now we are going to multiply it by the lowest common denominator here. So when we multiply by that, we simply get this quantity. And the best strategy is what? Just to square both the sides. So what that will give you is 4x square equals how much? 4x square equals square here. We'll just remove the square root sign, x square plus 4. And then if we move x squared to the left-hand side or subtract it on both the sides, we have 3x squared equals how much? 4 then, right? So x will be plus or minus, let me write it in the next line. So x would be how much? That will simply be plus or minus 2 over square root of 3, right? When we divide by 3 and take the square root. So we will discard the negative value here. So what is the proposed value of x? Because we are looking at a distance here. That's 2 over square root of 3. All right. And to determine that that indeed will give us a minimum, we may go ahead and look at the second derivative, or we can see whether the function increases or decreases on both the sides. I think second derivative might be easier, but you may do it the other way if you want. So for the second derivative, we have, and you can do this, you can see that the derivative of 4 is 0. And here you can either apply the quotient rule or split them as product of two functions, whichever way. I'm leaving the calculations on you. This will be the second derivative. And the second derivative you can see right here is x squared plus 4 to the 3 over 2 in the denominator. The numerator is constant, so that's positive. That means the function is concave up everywhere. So at the critical values, we will have what? We will have a min. All right. So what we would, or actually absolute min in this case. And actually, let's just, examine one more point here. We had dismissed this value before, and we are dismissing it for two reasons. One is that, well, negative values didn't pertain to our distance notation. And at the same time, I cannot have a negative value as a solution in this case. So when we squared it and found the solution, this is what you call extraneous solution. So this will not apply in our case. All right. And we can conclude that x equals 2 over square root of 3 kilometers would give us the minimum expense. And if you want to calculate that, all that you have to do is, remember, this is what we are minimizing. We can just bring it back to original, okay, and before or after, whichever way you want, and go ahead and substitute this value in place of x, and that will give you the minimum value. And we can confirm our answer by graphing it in Desmos right here. We have the point of minima, or for the minimum value, we can have this here. We will replace x by 2 over the square root of 3, okay? And sorry about that. Here, come on, okay? Right here, okay, very good. And this is also 2 over square root of 3, okay? And that comes out to be this quantity. And of course, we have to multiply it by what? Multiply it by 100,000. Okay, so let's do so. 100,000. So how much is it? It's about 3,785,640.65 if I didn't do any mistake in my reading. All right. So let me know if you have any questions.